So good morning, good afternoon, and welcome to the market dialogue on greening humanitarian responses through enhanced solar energy harvesting. My name is Ransha Basnaid, and today I'll be a moderator for this webinar. So today, this webinar is organized jointly by IOM UN Migration, USAID, European Union Humanitarian Aid, and University Politecnica de Valencia. So before I go quickly into the agenda, I wanted to first welcome all of you one more time. Today, we have a very diverse set of stakeholders representing private sector, research, and a lot of different other fields. And today we are here so that IOM can present its new project on how to use the excess energy from solar pumping projects for productive uses. But more on that will be explained by IOM shortly. So a quick look at the agenda for today's market dialogue. So we want a quick kickstart with a presentation from our colleague from IOM, who is going to introduce what is the project about, what are they trying to aim, what is the aim and objective of the project. And then we are going to move to our colleagues from Politecnica University of Valencia, where Professor Salvador is then going to dive into the research component or the technical component of the project. And during all of this time, you have an opportunity to ask questions because we want to use this webinar or this market dialogue as an opportunity to engage you, the stakeholders who are present in the call today. So please do use this opportunity to ask any questions that you might have to IOM and to Politecnica University using the chat function, or you can also use the Q&A function and so on. And in case we do not manage to answer your questions today, we will answer all of these questions in a follow-up, so that please be assured that all of the questions asked today will be answered. And please do engage with us using the chat, and all questions are welcomed. And what we will do is during the two presentations, we will compile all the questions, and then during the Q&A round towards the end, we will then ask the questions to the respective speaker. So without further ado, I would like to invite my colleague Alberto from IOM UN Migration. Alberto is the Wash and Energy Manager with over 15 years of experience in the sector. And today, Alberto is going to give us an overview about the project, what it is about, what is the aim, and so forth. So Alberto, I would pass the floor to you to give us an introduction to the project, and over to you.
Thank you, Ranisa. Hello to everyone. Let me just share my screen. That will stop sharing yours, Ranisa. And okay, so you should see my screen right now.
Yes.
Yes. Okay, so hello to everyone. Let me reintroduce myself. Again, my name is Alberto Ibáñez Llario, and I work for the United Nations Agency for Migration as a project manager in the fields of water and energy. And today I'm going to introduce an innovative project that we started a few months ago with support of BHA, the USAID Bureau for Humanitarian Affairs, and ECHO. So a little bit of background to this project. For the previous almost 6 years, we at IOM had been managing something called the Global Solar and Water Initiative. This was a project aiming to mainstream the use of solar energy in water supply projects across the water relief sector worldwide, especially focusing on relief context. We aim to work with anyone interested to know and to start using solar water pumping solutions in their programs. And as you can see there in the screen, we did a lot of country visits, field assessments, online and on-site trainings, produce a lot of knowledge material, and engage with many different, mostly NGOs, but also governments, other practitioners, universities, manufacturers, donors, and so on. What we have seen in this period of time is that the number of solar pumping schemes installed by relief actors increased from several dozens that we managed to map back in 2015 to over 4,000 solar pumping schemes installed in the last 12 months up to March this year. From more than 500 installations in Yemen alone to solar schemes tracked in around 40 different countries. We know these are just partial mappings, but what is clear from these and other proxy indicators is that the use of solar water pumping technology in relief and other contexts have grown almost exponentially in the last few years. And we know there are many more systems out there installed that escape our radar. The reality today is that solar water pumping technology has become a default choice in a good number of humanitarian and development contexts, and it's favored by users, by organizations, governments, and donors across regions. So the numbers are there. The quality of installations probably is something that in some cases still have to be improved, and that will be work for many of us for years to come. But late last year, we felt that the main goal of that global solar and water initiative that was mainstreaming this solar pumping technology in relief context was somehow mostly achieved. We started to think what else we could do to benefit users and practitioners using solar technology in their water projects. And in the graph that you can see there, what we are trying to show is the fact that water pumps, as you may know, have a minimum and maximum power pump capacity. Pumps are not able to use more power than its rated maximum power or less than its minimum. When we design solar pumping schemes to increase the water daily capacity and be able to pump more water from early in the morning to late in the afternoon, one needs to provide more power to the pump. And we do that by adding solar panels to the system. Excuse me. Therefore, especially at peak solar power around midday, there is always a surplus of energy that the pump cannot use, because there is nothing else connected but the water pump. That energy is not produced, or in other words, is wasted. We knew this for some time, but never really stopped to quantify how much that surplus energy was. And I think that happened till we were assessing an installation in the Ethiopian Somali region, where there was a system designed by an NGO to supply a minimum of 100 cubic meters of water per day, 100,000 liters per day, any day of the year, and that's what is expressed on the blue bars on top of the slide. And during that assessment, well, the system worked well, supply the water as intended, but the community approached us to ask if they could charge the mobile phones somehow or have some lights in the community at night. It is then that we revisited the design of that particular system to realize that the pump was on average not using 38% of the energy generated by the solar panels, or 41 kilowatt hour. Yeah, that's the red bars on the bottom of the slide. So the pump is working when there is energy in between the two dotted lines. Anything below or above, the water is not, the pump is not able to use, and therefore it goes wasted. And that was, in that case, 41 kilowatt hour on average. Now, to realize a little bit how much is 41 kilowatt hour, or how much is that unused energy, and what you can do with that, what we did is to select 5 existing solar pumping schemes in 5 different locations and from different sizes. At the table there, you see the first system here. Let me point it. The first system here in Ethiopia, in Jijiga, is a small system serving 600 people at 20 liters per person per day. And with the panels installed to supply that water, there is a surplus unused energy of, on average, 6,063 watt hour per day. Yeah, and that was 62% of the energy that the panels could generate for that system that was never used. If you go to the one in the bottom, which is the largest one in Sana, in Yemen, that's a system serving 15,000 people and having over 800 kilowatt hour, or 25% of the energy unused. Here in the green table, you see all the things that in theory could be powered by that unused energy for each system, considering that 40% of it is lost in transmission and storage. So for example, for the first system, we could charge every day 300 mobile phones. We could light 10 lights for 8 hours. We could power a TV for 4 hours and have maybe some ceiling fans in the school or in the community center, 8 of them working for 8 hours. So we could do all that with the energy that is never used at that solar pumping scheme. And you can see the same kind of theoretical exercise for all the systems. For the one in the bottom, the largest one, you see how many things you can do there: charge 7,500 phones, and light community center, power a small health center, internet cafe, and so on. Yeah. In the blue column here on the right, what we are trying to express is the extra energy that you could have for every hour when the pump is not working. So say that, for example, the water tank is full, you switch off the pump. So all the panels that are connected to that pump became now completely unused. And so that will provide extra energy to add or to power more appliances. In summary, we realized that the amount of energy unused at almost any solar pumping scheme that we look at was a sizable amount of energy, and the possible applications were very interesting for the context where we work. So basically, if you think that we have already installed thousands of solar pumping schemes, and we are going to install thousands more, many of them in off-grid or weak grid locations, you might start thinking that there must be a better way to use those schemes and the energy generated by those panels. So what this project is proposing is to pass from the idea of single pumping schemes, as we do nowadays, to what we call solar community hubs. And what we are looking for is a simple plug and play technology that will allow us to supply the same amount of water than with traditional solar pumping schemes, but that also will allow us at the same time to use that wasted or unused energy to power phones, lights, or other appliances. Yeah, so to move from what you see in blue on the left, the single-use solar pumping scheme, to the multi-use solar pumping scheme. How we see this is that these could be fundamentally water projects with an extra component of clean energy provision. And we are not trying here to supply electricity for everyone in the community or for all the possible uses or for 24 hours a day. It's just about meeting some of the most pressing energy needs in the communities. This will not intend to be a replacement of other rural electrification technology or mini-grids, but mini-grids, for example, are going to take decades to get to everyone and advance at a slow pace, are much higher cost and many times based on complicated financial assumptions to ensure their long-term sustainability, while we are installing already thousands and thousands of solar pumping schemes per year that could serve as a stepping stone for communities to have not only water, but also some kind of clean energy access. I have been asked in recent times, and we discussed with some people about the advantages of looking at this in an integrated or separated way, having on one side water and on one side a separate project for energy provision. How we see the extra advantages that we see in trying to provide this in an integrated way. Some energy access from water projects rather than doing it in a separate way is that firstly, in water projects, there are already established management models and fee collection systems to ensure the long-term operation and maintenance of the schemes. That's already there and it has been working for decades. We don't need to invent anything new, and that's a great advantage. The integrated approach opens new avenues for better financial sustainability. And as I said, this is vital because it is, for some other kind of energy project, is so difficult to find models that ensure long-term financial sustainability of the schemes. So that's a very big advantage already there. Secondly, there are already few thousands of water engineers working in field locations, especially in humanitarian context, that could, with a brief training, become knowledgeable enough to design and supervise the installation of these kind of schemes. The same way they became knowledgeable enough to start using solar panels in their projects in recent years. So the possibility to scale up at the speed and provide energy to thousands of communities in the short term is there. The third point is that there are multi-billion allocated budgets for water projects every year, since water is a cluster in the humanitarian system, something that doesn't happen for energy projects. And lastly, we think that this integrated approach will mean also a better asset and better water resource use, more efficient use of the equipment and the water resource, opening more options for better social engineering. In summary, we think we have, as a sector, as a water sector, the budgets, the engineers, and the management models to make a change happen to scale and provide not only water, but also clean energy access to thousands of communities in the short term. So next time that you install a solar pumping scheme, think that there is a sizable amount of energy that will never be used by the equipment, and that maybe then you will perhaps want to know more about what to do about it, or at least that is what it started to happen with us at IOM now. So let me go to the final slide. Oops. This is the final slide, sorry, which are the phases of the project, as you can see in the screen. What we want to find and test at the lab, we want to find and test at the laboratory of our partner and at field locations, the right components to provide water and energy from solar pumping scheme as explained. Once that happens, we will follow the same logic than the past Global Solar and Water Initiative. That is to create and share knowledge material, to offer technical support and free trainings to whoever is interested to know about how to provide this kind of water and energy from these kind of schemes. And we expect that many of the few hundreds of organizations we already engaged with in the past and that are already using solar pumping technologies will be recipients of this new support. This is a fully funded project for 3 years. And so in principle, we don't need more funds to carry out the activities as planned in the project. If you are a donor or a foundation or the like, and you are interested to be part of this project for, because you are active in this kind of field, or you see the potential, or disconnect with other projects you are funding, or any other reason, we can always talk and increase our capacity in the testing and the piloting phase, or add other new activities to the project. So we can always talk about it. But what we are primarily looking for in this market dialogue is first, get to know our project and work to you all. Second, get to know other organizations that are exploring similar lines of work or have some learning to share with us. Third, connect with organizations, research institutes, universities, manufacturers, etc., that can bring their knowledge, their engineering power, or maybe already their existing products to add value to some of the phases of the project and develop these solutions with us. And if you are into one of these categories, I will ask you to please drop me a line to the email that appears here on the bottom of the screen, and so we can have a one-to-one talk. If you're an organization that are less into the research side of things, but you could be interested to have some pilots in the locations where you work and have extra funds to pay for it, also contact me and let's talk. Yeah. So I think that is all from my side. I hope you find it interesting. Thank you for your attention. I hope to get some emails from some of you. And thank you again, and back to you, Ranisa.
Thank you so much, Alberto. And I will thank you. Now I'll quickly share my screen. Perfect. So first of all, thank you again for that introduction to the project and also giving us the background on why this project and why you are working towards this to achieve this goal. We do already have a lot of questions in the chat that are talking about the backgrounds and how they can get involved and so on. We will address all of them shortly after Dr. Salvador's presentation. So please do use the chat to put in all of your questions. And in the meantime, I would like to invite Dr. Salvador Següe-Chile, who is the professor at Polytechnic University of Valencia since 1991. And since 1999, he has been involved in different areas of photovoltaic installations, and currently is the director of several courses in PV systems at the uni. And he has decades of experience in the sector. So Professor Salvador, I'll pass the floor over to you, and we would love to hear more about the technical or the research component of this project. Over to you.
Many thanks. I'm going to start my presentation. 1 second. Can you confirm me that you have seen my presentation?
Yes, Professor.
Many thanks. Good morning. My name is Salvador Segui, and during the following minutes, I will share with you the first outcomes obtained as a result of our research in battery-based PV pumping systems. I'm part of a group of 6 professors of the Polytechnic University of Valencia. A new engineer is going to join us our group in December. We all have previous experiences in PV systems, power converters design, water pumping systems, and monitoring systems. The basic structure of a direct water pumping system is shown in this slide. The block diagram includes the components that we have in our facility, located in one of the UPB buildings. We have 8 modules in series with a peak power of 2.5 kilowatts, 2.4 kilowatts, sorry, a 2.2 kilowatts variable speed drive that is used to manage the operation of a 1.5 motor pump group. And you can see in the diagram where is the PV field, the controller, the variable speed drive, and the motor, the submersible pump. The rest of the circuit is just the hydraulic circuit, that is just this part, and consists of a tank that includes the submersible pump located in the basement of the building, and another tank in the roof, as will be shown in a following slide. Our research is focused on the use of lithium-ion batteries in PV water systems, as is detailed in this block diagram, installing the power converter and the battery between the PV field and the variable speed drive. So this part of here is just common to the direct PV water pumping systems. Main advantages and disadvantages of battery-based PV water pumping systems are well known, highlighting that in a battery-based systems, the energy not used for pumping can be used for other purposes, as Alberto has been detailing. We can use for the charging of battery banks, lighting, or other uses, which can add value to the PV system in humanitarian aid environments. This is the block diagram of our facility. The hybrid inverter, this part, manages the power flows between the PV field and the battery and the loads. Here is the water pumping systems and other additional loads that we can see in the diagram. The hybrid inverter is operating in off-grid mode and can include an auxiliary generator in the AC port to charge the battery and keep the pumping system working when irradiation is low. The variable speed drive has, like the additional loads, are connected to the backup output that provides a single-phase AC system in the output here. PV pumping systems are unusual off-grid systems because they don't require a battery for operation. Size, the instantaneous power flow can be controlled with the maximum power point tracking algorithm that establishes the point of operation of the PV field, and with the control of parameters of the variable speed drive output, voltage, current, and frequency applied to the motor. In the rest of cases, with loads that do not permit a regulation of the demanded power, the inclusion of an energy buffer, the battery, is mandatory. The following slide shows the different parts of our facility and details some of the main characteristics of them. We started using a 48 volts battery with 3 kilowatts hour, but nowadays we are working with a battery with 11.5 kilowatts hour and working with a DC voltage of 230 volts from Solax. The first results obtained with the 48 volts battery-based solution are described in the articles described here or detailed here. In the following slides, I will present a summary of the main results of these articles. The monitoring system is based on a commercial solution from Carol Gavassi and permitted us to obtain the efficiency in the different parts of the water pumping system. Here on the left, we can see irradiation, the PV power, how the power that arrives to the variable speed drive is reduced due to the losses in the conversion. And the last one, the blue line, corresponds to the hydraulic power. It's interesting to note that while the motor pump group efficiency, described here by the blue line, is quite constant with a maximum at rated conditions, here, the variable speed drive shows the maximum efficiencies in the low power region in these two parts, with an important decrease at rated conditions. Rated conditions are just in the middle of the day when the power is maximum in the PV field. The following figures summarize the first comparison of the direct-based solution with the results obtained with the battery-based solution and the water pumping systems operating at rated conditions with 50 Hz in the motor pump group. While the flow rate in the direct solution varies from 1 liter per second with the minimum irradiance to 2.59 liters per second with the maximum power provided by the PV field. Here we can see that in the battery-based solution, the system operates continuously at rated conditions with a flow rate of 2.59 liters per second, regardless of the irradiance. We can see here how is the power, the hydraulic power in the battery-based solution. Some results were obtained with the battery-based solution and the water pumping system operated at rated conditions, 50 Hz for the variable speed drive. It was verified that by operating the variable speed drive with a frequency of 30 Hz, as we can see here and here, the overall efficiency was optimized. The pumping interval was extended and a greater pumped volume was obtained. As you can see here, we have extended the pumping time after the disappearing the irradiation. To increase the efficiency of the battery-based solution and better use the energy stored in the battery, the efficiency in the water pumping system was analyzed respect to the frequency of operation of the variable speed drive. Here in this graphic, we can see the different values from 30 Hz to rated conditions of the motor in 50 Hz in the variable speed drive. This frequency is the parameter that controls the power demand of the water pumping system. As can be observed, values in the range of 30 Hz. Here we have the total efficiency of the system, that is the red line, and we have plotted in this part only this total efficiency to see that in the low frequency range, the efficiency reaches the maximum values. Results obtained shows that the pumped volume in the right side here. In sunny days, in this part of the graphic, in which we are representing the peaks and hours, are quite similar for both solutions, for the battery base and the direct solution of the direct water pumping systems, with a greater volume production for the battery-based solution in the case of cloudy days. Cloudy days corresponds to days with a small value of the peaks and hours. The following slide shows results obtained with a high voltage battery-based solution in sunny and cloudy days. Remember that we are working with a battery of 11.5 kilowatts hour with 230 DC voltage in this new system. For the cloudy day that we are showing in the right side here, the value of the irradiance did not reach the level to start the pumping during all the day. We can see that the maximum is smaller than 300 watts per square meter. That is the minimum irradiance level to start the pumping. So no pumping volume will be available during this day with the direct solution. For a daily total of 0.97 pixels, that is the irradiation of this curve, the PV energy generated along the day is greater than 2 kilowatts-hour. Under this low irradiance condition, the battery-based solution was pumping during 41 minutes, as you can see here. This is the length of the pumping interval, with a total volume of 3.98 cubic meters, keeping the state of charge of the battery in the same value at the beginning and end of the day, as you can see here by the state of charge of the battery. We are presently evaluating the PV water pumping systems that can emit a hybrid inverter to include a lithium battery in the system, transforming it in a greener and sustainable solution. The amount of energy that can be obtained for other uses without affecting the pumping of water, how the energy efficiency can be optimized, and how we can use this energy in other appliances are just the most important topics that we are trying to solve in the next stage of the project. Collaborations with other partnerships is welcome to the topics detailed in the slide. Within our planning, we are analyzing existing or future commercial solutions that might be of interest in the implementation of this solution in medium and high power, trying to develop systems in the order of tens of kilowatts. Although the compatibility of the PV field between the two solutions, the battery-based and the direct solution, is an initial goal, the PV field can be extended if it's designed considering the greater range of the PV input of the hybrid inverter that usually has a very wide values for the voltages that we can emit in the PV input. To determine the amount of energy that can be used in other appliances other than the water pumping, and permit the connection of these appliances, an energy manager is needed in the system, combined with Internet of Things devices for the on-off control of these extra loads. As you can see, the idea is to control with this manager the connection or disconnection of these extra loads in the output of the hybrid system. Until now, we have used the connection of the water pumping system, that is all this part, in the backup output of the hybrid inverter, in the AC output of the system, with a single phase AC voltage for low powers, although this solution is also valid for medium powers if a hybrid inverter with a three-phase AC voltage is used. With the increase of the battery voltage in the lithium batteries, that nowadays can reach values in the level of 800 volts without problems, we can find values in this range, the direct connection of the water pumping systems can be investigated. The connection of the water pumping systems directly to the battery has a solution that optimizes the use of the energy stored in the battery, because we are avoiding the losses in the DC-DC converter or in the DC-AC side in order to obtain an AC signal. So the energy will be betterly used in this structure. I hope you found the presentation interesting. Thank you for your attention.
Thank you so much, Professor Salvador, for that interesting look into the presentation. And I think now we are ready to move into the Q&A round. And I see, Alberto, you have already answered some of the questions in the chat. So thank you so much for that. And Professor, if you'd like to stop sharing the screen, that would be great. And maybe before we move into the Q&A round, Alberto and Professor Segbe, my first question to you would be, again, for our stakeholder to understand, if they were to get get involved in this project? Maybe if Alberto, you could repeat what kind of supports would IOM provide, or what kind of partnership is IOM looking for, which you talked about in your presentation already, just to start the discussion again with that. And also how they could make use of the research facilities that Professor Salvador just presented. So maybe if we could start with that and then go into the questions in the chat. You are muted, Alberto.
Sorry, thank you. Thank you, Anissa. Well, because we are now in the pilot phase, and as Professor Salvador was explaining, we are trying to test components and different layouts. We have a focus on that phase of the project. So, for example, one of the things that I was saying at the in my last slide is you are a university that is doing research into this kind of field and similar kind of stuff. Maybe you are looking into also how to maximize energy from panels, or you are looking for batteries, working with the last generation of lithium-ion batteries, or any kind of power electronic components that you think, oh, this could fit well here. If you see a connection, or you have a lab or a team that would like to join Professor Salvador's team, because you have any interest on this. So research institutions, universities, or even manufacturers with their engineering department that want to look into this, or maybe they are already looking into this, and we can work together to test. That could be something that we'll be very interested to hear about now, because now is when the testing and finding the right layout and components and schemes is coming. Yeah, so that would be one kind of collaboration. The other one, of course, if someone is already working into this, to let us know their learnings, the lessons learned, and that we could also take to advance faster in this phase of the project. If you are working more in the field and want to see some pilots, well, we have funds for pilots in the field, but we already have practical action working for us as partner in this project, and we ourselves, IOM, that are working a lot with solar pumping technology. So I would say that those funds are mostly allocated for these two organizations to pilot in the field. You have funds and you want to pilot because you are interested on this, we could work together. But we don't have funds for pilots, for more pilots. Yeah.
Thank you.
Finally, if you are a donor, a foundation, if you are an institution that have some funds and think, oh wow, this has potential, or I would like to collaborate here somehow, we could then support more pilots or other activities that will make us advance faster. Yeah, as I said, the project is fully funded for 3 years, but that will add value to what we are doing, because more pilots, more testing, or working with other institutions, having funds for that, of course, will help to make this all more robust or more solid even.
Thank you. And just a follow-up question to that would be then, is there any geological area that you're focusing, or it's a global call to partners all over the world to join hands on this project?
No, partners all over the world. Pilots are more in, because our donors are humanitarian. So, of course, the interest is that we can make these things work in humanitarian context as well. Yeah, because of course, it's like solar pumping technology. You can use it in many other contexts. Yeah, but there is a focus of piloting, and later on when we start doing training and we start producing knowledge material, we will tend to focus more on humanitarian partners, humanitarian context, yeah, but not exclusively. But, yeah.
Perfect. That's clear. Professor, if you'd like to add anything to that, please feel free to do so. Or of the Research Institute or anything you'd want to add on the collaboration part on that.
Well, I find that the answer of Alberto is perfectly adjusted to the proposal of the project.
Perfect. And to all our attendees who are listening to us right now, what we will do is I'll also request my colleague now to drop in the chat a survey link. And the idea behind this survey link is if you are interested in reaching out to Alberto or Professor Salvador on the next step of the project, or if you want to involve in any ways, you can use that survey to share your contacts and what you are interested in. And based on that, we will then reach out to you individually to discuss the next steps. So I'll request my colleague to put it in the chat. And in the meantime, let's go through the questions that have come in the chat. So there were a couple of questions that were about the oversizing of the systems, but Alberto already answered those. So maybe we will move to the other questions. And then the other question specifically with regard to the project is there a focus on already installed solar pumps? Or sorry, let me just quickly read that question is the focus to work project on already installed solar pumps or to anticipate every time when a new pump is installed? So over to you, Alberto.
Yeah, well, the idea that we are working with Professor Salvador team is is both. Yeah, it's something that can be retrofitted into existing schemes, or you can do it from the scratch. There is a focus, I will say. I had that question recently, actually, from the donor side, and they say schemes that are installed are a few thousands, yeah, or some thousands. Schemes, solar pumping schemes that will be installed in the future are many more. So, especially focus on those many more that are coming. But we believe that if we find that the plug and play solution, hopefully we will be able to revisit, other installed schemes. I don't know, Salvador, if you want to add something to that.
Well, I found that the technical solution can be valid for existing PV water pumping systems and for the future solutions that we are analyzing.
Perfect. Thank you so much. Then, Professor, the next question is actually for you. So you talked about different types of batteries. So the question is, can you use other batteries other than lithium-ion solar battery in the research projects that you talked about?
Well, nowadays, the market of batteries is moving since 2018, more or less, to lithium-ion batteries. So lead-acid batteries are not disappearing from the market, but in this type of solutions are not just interesting. Chinese manufacturers of hybrid inverters are all producing hybrid inverters intended for lithium batteries, not for lead-acid. They need to adjust. If you want to use lead-acid batteries, you need to modify some of the configurations of these devices. So it's just not the trend of the market.
Thank you so much. And the next question is also about the cost analysis that was carried out. So a comparison between 11 kilowatt hour battery peak and a complementary genset to take relay in a hybrid system. And after how many years the battery option becomes a cheaper option than a hybrid systems, and the cost analysis that you showed?
I think that Alberto could give more information about this economical part, but nowadays, from our point of view, what we are trying to do is to evaluate the technical solution, find the best point of operation of this solution or the best conditions for the operation of the batteries in this type of systems, and waiting in some way a decrease in the prices of batteries. So I know that in the next years, we are going to see a sharp decrease in the price of the batteries. So these solutions will be competitive in some more years. So in some way, we are advancing in the technical solutions in order to weigh the economical point of interest of these solutions. But I think that Alberto has been doing this type of economical analysis and can give some more information.
Thank you. We have done a lot of economic analysis in the past for systems not including batteries. And as many of you know, hands down, the replacement of diesel generators by solar pumping systems is, from the economic point of view, very interesting with very short return on investment periods. Now for batteries, we need to look at it. We haven't put the numbers there yet because we are still looking for the right components and what we can get from that and what will be an equivalent system with working maybe with a generator instead of batteries or working with grids. And of course, is part of the project to do this economic analysis. There are two drivers of the solution that we are looking for. One is going to be simplicity. It has to be simple enough for people to be able, as I say, maybe with a brief training, the same way we did for solar pumping, to be able to apply this kind of things or design and supervise a contractor to install these kind of things in the field. The other one, of course, will be cost. Without the cost, it's going to be the possibilities to scale up this to the thousands of systems out there that, as we said, is going to be limited. But we are confident. That will be there for two reasons. One, the one that Salvador mentioned, prices are coming down for lithium-ion technology, and the second, because we have seen in the economic analysis in the past that it is so expensive to maintain and fuel those generators. Think that to supply water, you need to have those generators working in working order and with fuel every single day. It's so expensive over the lifetime of the equipment that it leaves a lot of room for other technologies to be more cost efficient. Yeah.
Thank you so much. And on the same line about the technology, so if partners are going to collaborate on developing this technology, is the technology then going to be publicly available in terms of accreditation or in terms of owning the technology? Would that be a public open source technology that anybody would be able to use, especially if private sectors are also involved in the research? How would that work out?
Salvador, I don't know, you have something there to say, or you prefer me to go ahead?
You can answer. I think that our idea is to analyze different solutions, and just like you can see in my presentation, we are publishing the results in open access journals, so it's something that all people can access to read and implement.
So really the focus is on open knowledge sharing and not limited to one organization. That's the idea we are going towards.
Yes. So our idea is to work with Alberto in the development of the systems and share the knowledge with people interested in this type of applications. We have several courses of PV installations in our university in which we share the knowledge that we have in this type of field. So we are more interested in the training and in the development of the solutions than in mount a company for selling this type of systems.
Albert, do you want to add something?
No, I think he already replied, and I see again is we are taking our experience from the Global Solar and Water Initiative to this project. And in the past, all that support. I mean, we have helplines to support implementers, to answer questions, to provide trainings, to produce knowledge material. I mean, the idea is that all that is open for anyone interested, because yeah, the idea is that if we come to with this kind of solutions, these are used in the field. Yeah, that's the end goal of this. Is not to retain this for IOM or for any particular organization. Yeah.
Thank you so much. Then in a follow-up email, we can also share the link to the Global Solar Network so that those colleagues of ours who haven't heard about it can have a look at it. And I think that's also interesting for our audience, because in case they don't have anything to directly collaborate right now, maybe it's a good thing to can stay tuned about the project. And once the results are published, it might be something they would also be able to be used in future. So now going back to the questions in the chat, there were two questions questions/comments, which were about the use of chlorine through electrolysis to use the excess electricity. So the question to both of you, if you have looked into it, or just comment on that idea. Since both you are nodding, okay, go ahead.
No, I mean, I guess it's a question of seeing how much energy they use for that, and you know how much we could get from those particular systems. Yeah, it's not intended to be used just for, I mean, lighting a bulb or powering a phone. It's energy that will be able to be used for whatever use is interesting for the particular community of users. So for that question,
You are muted.
oh my gosh, I did all that.
No, you were saying for that particular purpose, and then you muted yourself. So.
Okay. So there is no one particular purpose, you know, to use that electricity for. So for that particular case, it's just a question to see, okay, what pump you have there, how many panels, you know, you need how much for that electrolysis, and then see if it's feasible. What is interesting is also that now that we know that if we come to this, no, and we think, oh, we can use that excess energy, we could, I'm going to use it for that electrolysis, and I should have installed 3 more panels than the solar pumping software is telling me. We could, you know, proactively add those, you know, 3 panels or whatever we need, because we are already thinking that we are going to use the excess energy. So those possibilities are going to be there as well. I think that solar panels nowadays, the cost is so little and they last for so long, that we strongly believe it will make sense in a more advanced phase of the project to have that thinking. I want to provide this water, but I need this energy for that use that the community wants, or because I want to use it for electrolysis or something else. So I'm going to design my solar panels to be able to respond to both those both needs. No?
Definitely, I think, and that will open new doors also.
I want to add some more
please.
information. If you revise one of my last slides, other loads can be connected to the systems, and the energy manager is the device or the controller that will decide which type of loads are permitted in the system, because depending on the power demand of the hydrolyzer or the other loads, we can permit or not permit the connection of this type of things in the system. So depending on the loads that the community wants to connect in the systems, the design can vary. We can need a different hybrid inverter with a greater power or a bigger battery. So this type of things at this point are not considered, because we can find a lot of different type of applications. So we are trying to see the most common loads that can be connected in the systems, limiting in some way the maximum powers that we can provide. But in the future, we can increase these powers and we can adapt the design of the system to other loads. So there is no problem to connect an hydrolyzer.
Definitely, I think, and that also opens the field much wider with new loads and so on. Thank you so much. And now going back to the Q&A, we have a couple of questions which are more about the background of the project. Alberto, you answered some of them, but maybe if you could again talk about all the examples, all this extra load, and the question was about is it over designing of the system, and you answered that in the chat, but I think it's a very valid and very relevant question. So if you could again explain it, we really appreciate it.
Yeah, thank you, Ranisa, because I wanted to come back to that question because it's often there. It's often there, and I understand because you know, when you see a system that is not using 60% of the energy, you wonder, you know, what are you doing there? But that's the reality. I mean, those systems were designed with professional solar pumping software, and the issue there is that the aim of those schemes is not to make an efficient use of the energy. The aim of those schemes is to provide a certain amount of water. Yeah, we don't care when we or the professional designers don't care if 60% of the energy is used or not used. Yeah, what you care is that you are providing a certain amount of water every day of the year to the community. Yeah, and it's very often that we, in order to maximize the amount of water that we want to provide, we want the pump to start working early in the morning when there is not a lot of sunny radiance, and too late in the afternoon. And in order to make the pump work and provide you know, as much water as possible, we add panels, and that's fine. That's the right design. You know, these are not wrongly designed, because if, for example, for that particular system, the small system that has 62% of unused energy, if we fit the panels so that all the energy or almost all the energy is used, we will never achieve the water that the community needs, and that will be a big problem. Yeah. So it's not a question of a wrong design. Again, all those systems that I saw there, and I look into this with my teams in detail, and we were in contact with some of the biggest manufacturers in this field. They are rightly designed. It's just the way you do things to provide water that leave all that energy unused. Yeah.
Thank you so much. And then the second question that's also about the background would be, why are many humanitarian actors still facing basic OM operational maintenance issues like lack of cleaning, dust removal from panels, efficiency issues, and so on?
I think that's one that's more for me. Well, you know, I was having I was participating in a dialogue on drilling of boreholes. Yeah, and what we see is that, you know, this is something this is something that we have been doing in the waste sector for decades, and we still find so many cases in where things are not done properly. Yeah. Now, if you put into comparison solar pumping technology, which is relatively new, especially in the humanitarian sector, I'm not surprised to see that, you know, there is a learning process there. You cannot expect that everything is done well from the beginning with a technology that is relatively new. And it doesn't matter that we have trained over 1,000 of water engineers in humanitarian, different humanitarian contexts, because people come and go. Yeah, you train someone, the following year there is another one who is not that familiar with the technology, need retraining. We have seen a lot of kind of issues, but especially operational maintenance is a big one, because we believe engineers tend to get a little bit more interested or excited when it comes to design and installation, and also because the way humanitarian people work with short span or I would say narrow window times to do things, we tend to put less attention on the long-term aspects of the projects. So things that are very basic and easy, like teach the community that they need to clean the panels with water and a cloth, many times we found it's not there. It's not complicated. It's just people need to be reminded, and that's how it is. But I would like also to say that since I started doing trainings back in 2015, I've seen a lot of change when I visit the schemes in the field. Yeah, a lot of change. People are in general more knowledgeable. Different organizations have developed their own knowledge material. And you can see also a change on how they select knowledgeable contractors, quality products. So things are not perfect, as it is not perfect for other technologies that have been there for long. And that's work in progress to reach the right quality. But I think as a sector, we are moving in the right direction. Yeah.
Definitely. And maybe would it be fair to also add that humanitarian sector specifically comes with its own added challenges, which you will normally not find in other contexts, which you have the time pressure, you have a lot of other external factors that influence on-ground work. So maybe that could also be one of the reason of the challenges for implementing such projects. And we actually have one comment from one of our attendees about increasing the efficiency. And the question is, have you looked into, excuse me, have you looked into having maybe 50% of panels facing the sun in the morning and 50% in the afternoon to cut the top of the unused capacities and giving energy in the morning and afternoon with the panels facing in two different directions?
The solution described by this colleague is just interesting and common in some applications. I only have to recommend that if you are going to divide the PV field in two parts, it's because the converter, the power converter, has several maximum power tracking units. Because if you have only one maximum power tracker, then you have not to divide the orientation of all the PV field must be the same. So it's quite important. So this is one of the advantages of hybrid inverters, because usually they have at least two inputs for different PV fields working in different operating conditions. But the variable speed drives that are directly connected to the PV field only has one maximum power point tracking system. So in this type of cases, you cannot separate the PV field just like is suggested in the student. So you have to analyze the different solutions and decide.
Thank you so much. And I think that was a really good discussion about the solutions being presented by our attendees and so on. I think we have one more comment, so I'll kind of quickly, also it was a thanks from the attendees. I think we are kind of running out of questions that are in the chat. I think one question that we haven't talked about is again about the background question was, why do we want to move to solar community schemes before ensuring that we have achieved our objective of removing diesel generators in existing hybrid schemes? So Alberto, I think it's more addressed to you.
Well, maybe it doesn't have to be one thing or the other. We can explore new solutions while in a specific context, like this colleague was mentioning. I think it was in refugee camps. We can also still keep working to, remove diesel generators. But after so many field assessments and the schemes visited, I would also like to say that there is no magic solution for all the contexts. Yeah, even sometimes it's better, or it might be better to use a diesel generator or to leave the hybrid system there and not remove the generator, because the contextual factors where that system is installed. Yeah, so don't think that this come as a blanket replacement of existing technologies everywhere, anywhere. Yeah, you will have to analyze your context. It's not all about cost. It's not all about one specific thing. It's normally a number of factors that come together, and that you people that are in the field have to analyze and and say, well, for this one, I can remove the generator, but for that one, no. And in that other, I can put the solution that we are explaining here. So it's analysis will have to be there all the time. Yeah.
And context matters.
Context. Yeah.
Thank you so much. So with that, we went through all the questions in the chat, and we do have one question if they will be able to access the recording. Yes, we will share with you the presentations and the recordings and also the survey. Please do fill in out the survey, because after you filled in out the survey, we will then contact you based on the response, because there you have an option to indicate how you would like to be engaged in the project. So we still have 5 more minutes before closing this webinar. So if there are any last words or anything that either Alberto or Professor would like to share, please do so. If not, I will then shortly close the webinar as there are no further questions in the chat. So Alberto, yes.
I was going to give the
Okay, Professor.
The word to Salvador first.
Yes.
Well, I think that all has been running very well in the seminar. I think that there are a lot of questions, and I think that the solution for all the questions will we try to solve all these type of issues in the next stages of the project, because it's something that is new with very few previous experiences in the field. So, well, we will advance in this type of schemes, finding the better solutions for these people.
Thank you so much. So now over to you, Alberto.
No, perhaps that's something that is always in our mind. No, this is a really innovative project. If you do literature research, you find between little and nothing on some of the things we are trying to do here. So it's really new. We are learning as we move on. All the help is welcome from organizations that can add value to this. And also to say that we are also excited because we see the potential of the idea. No? And there are so many communities out there that are going to have to wait decades to have a power line coming to their community or to have a mini grid installed, but that they have already solar pumping schemes there. And you might think, oh, well, you can also only charge a few phones or light a few bulbs, but that's a game changer for communities that have no access to power at all. Yeah. So we think this will be or could potentially be a very interesting stepping stone for thousands of communities as they wait for those power lines and more bigger and more performance systems to get to their places. Yeah.
Thank you so much, Alberto. And from my side, for the next steps, as usual, my colleague has again dropped the link to the survey in the chat. We also dropped Alberto's email in the chat. So please feel free to use the email to contact either Alberto or also Dr. Salvador. And if you have any questions, please feel free to write anytime. And yes, we will share the recordings of presentations in a follow-up email with you. So I think with that, we really thank you for your engagement. It was a really engaging discussion with solutions coming from both the sides. So we hope to keep up this engagement. And like Alberto and Dr. Salvador has already mentioned, this is the start of a big project where the whole idea of having this dialogue was to really have this discussion with you, the experts, the different stakeholders, and so on, and to bring different kind of experience in this call together. So we hope you enjoyed it today too. And as usual, please feel free to send any suggestions, partnership requests, and all to the emails that were shared in the chat. And yeah, we hope to see you being engaged also in the second phase of the project. And until then, I wish you a good day and thank you so much. And thank you also to Dr. Salvador and Alberto for the amazing presentation and the discussions. Thank you so much.
Thank you, everyone, for coming.
Goodbye.
Thank you, Lisa. Have a good day.
Bye.
Bye.
Bye.